Hello students, and welcome to our continuing lesson here on analyzing and graphing tangent, cotangent, secant, and cosecant. In a previous video, we've already talked about tangent and cotangent. This time, let's talk about cosecant. And once again, let's remind ourselves what cosecant really means. A couple ways we can say it. It is r over y on the unit circle. We can also say that cosecant of theta is equal to 1 over sine of theta on the unit circle. And with that in mind, we can just start and use our graph right here to help us out. So I'm going to draw this relatively large here. And I'm going to increment this by pi over 2 units at a time. This is 2, that's 4, negative 2, negative 4. Okay. And in my graphing calculator, there is no such thing as cosecant, no such thing as a cosecant button. So the best thing that I can do is just use, there's all these buttons here, but no cosecant, so we're just going to use 1 over sine. So go down here, clear this out, and we're going to say 1 over sine of x. Using our standard window, you can see this graph starting to emerge, and it is a weird looking graph at first. Actually, it's always a weird looking graph, but once we can understand it more, it'll probably make a little bit more sense to us. Okay, so let me have this thing finish graphing here, and you can see that there's going to be some type of asymptote right here. It's going to be a bunch of vertical asymptotes that occur here, at this point and at this point. So I'm going to draw that in. It looks like the vertical asymptotes are occurring at pi, 2 pi, 0, negative pi, negative 2 pi. So let me go back to my graph, and let's draw these asymptotes. It's going to occur at pi, it's also going to occur at 2 pi, occurs also at negative pi, and a negative 2 pi. And also at 0. I mean, I should really say that the vertical axis here also contains it. All the way down there. And let's look back at our graph. You can see that it makes like a U right here in the first, between 0 and pi. Between 0 and pi, you can see the graph makes sort of a U shape right there. And from that, we can probably draw the rest of it with the help of our grapher. Oh, and one more thing, I'm sorry, sorry to keep switching back. You can see that the minimum value right here, the bottom of the U, right here, the bottom of the U, that's equal to 1. Okay, so we got to be very careful here how we draw this as well. So I'm going to make a pointer. This is 1. And our first item here occurs there. And then looking at the graph, there's a U, upside down U, and it has the tipping point of it, or the top point right here, is at negative 1. So this is negative 1, and the other U is going to be a little bit crowded here. It goes like that. And this function, again, is kind of weird, but it actually does repeat itself over and over again as well. Okay, all of these trig functions are periodic, because again, all of them are based off of the unit circle, which as we know, repeats itself. And so let's investigate this a little bit here and see, why is it like that? Why is it asymptotic? Why does it have these minimum points and these maximum points here? And to do that, well, I'm going to go back to my grapher, and I'm going to graph sine of x right on the same graph, so that hopefully we can see why this graph behaves. Let me graph it using green here, because orange and green will make a nice contrast for us. And you can see the way that the sine function is drawn. Once you can take a look at the sine function, I sketched it on here as well. The cosecant function makes a little bit more sense, because you can see that sine is 0. At this point, sine of theta equals 0. That means 1 over sine of theta is undefined. See? 1 over sine of theta then is undefined. So wherever you see a point where the sine crosses the x-axis, that means sine of theta is equal to 0, then it's going to be undefined for the cosecant function. Here it's 0, here sine of theta is 0, cosecant has a vertical asymptote. Once again here, and once again here. Okay. So we can say that for the cosecant function, it has vertical asymptotes wherever sine is equal to 0. And that's going to be at pi, 2 pi, negative 2 pi. Whoops. Theta is equal to pi, 2 pi, negative 2 pi. And we can just say very simply all multiples of pi. Can also say then that the domain is all real numbers except multiples of pi. Now the range is not straightforward as we think, but the graph certainly helps. You can see that all of the orange parts, which is the graph of cosecant, it touches everything from this point here on up and from this point here on down, but nothing in between. You can see there's a sort of a gap here where the sine function fills up that cosecant does not. So this is all real numbers from 1 and up, -1 and down. Okay, so this is saying from negative infinity to -1 inclusive, so from here up to -1, union with 1 to positive infinity. Okay. A few more things here. Doesn't have any horizontal asymptotes. Now it does have a bunch of extremas. And the reason for this is when sine is at its max, which are these points right here, 1 over sine, or cosecant of theta, is at its min. And vice versa. When sine is at its minimum, cosecant of theta, which is the reciprocal of that, is at its maximum. In other words, if you divide by a really, really big number for sine, you're going to get a really, really small number for cosecant. If sine is at its min, in other words, this number here is small, then cosecant is going to be big. So all of it has minimum values at 1, and these are all local. All of the maximum values are at -1, and again, this is local. So all these max here are actually occurring at -1. The minimum values are occurring at +1, which is somewhat of an unusual thing. And also, let's see if we have any sort of symmetry here. And looking at just the cosecant, if you take this, spin it around, it actually produces the same thing again. So the cosecant function, the symmetry, is odd. And finally, let's look at the period. And if we sort of take a snapshot right here, you can see that within this box here, everything just keeps repeating itself. All the other parts are just what's going on in this red box being repeated again and again and again. Okay? So the period here is also 2 pi because it's going from 0 to 2 pi. Okay? Same as sine, because really it's just the reciprocal of the sine function. So that's about all the details we can fill out here for the graph of the cosecant function. Now I'm going to erase all of this, and we're going to do this all over again, but this time with the secant function. And you can probably already guess what's going to happen here. But I'm going to erase all of this, and we're going to move on to example 4. And we're going to graph and analyze f of theta equals secant of theta. Okay? And once again, let's remind ourselves that secant of theta is really equal to 1 over cosine of theta. We can also say that secant of theta is r over x on the unit circle. And you're going to see a similar pattern. And what you really should do here is hit pause, see if you can graph this by yourself, maybe even without a graphing calculator, and then hit play and compare your results to my results. So again, this here is theta. We are going to graph secant of theta along here, and I'm going to increment my graph by pi over 2, pi, 3 pi over 2, 2 pi. Same thing in this direction. I'm going to go up to 4 up here, 2, to negative 4 down here. Okay? And I'm going to try to be really ambitious here. I'm actually going to try to graph this without using my graphing calculator. And we're going to try by start by graphing f of theta equals cosine of theta. So we know that for the cosine function, it starts out at a maximum, crosses over, does that, does pretty much the same thing on the other side, whoops, just like that, and it's going to continue this pattern here. Okay? So one of the things that I can use to help me, and I can state this very clearly, is that when cosine of theta equals 0, secant of theta is undefined. Secant of theta is undefined, okay? Because secant is 1 over cosine. So you can see here all the points on my graph where the cosine of theta hits 0. Let me label this clearly here. The green here is cosine of theta that I'm graphing here. Cosine of theta that I'm graphing. So whenever the cosine of theta is 0, I'm going to guess that there's going to be some vertical asymptotes going on here. So it's going to occur there, there, up here, right here. And then I can also say when cosine is at its max, when cosine of theta is at its max, secant of theta is at its minimum. Because when cosine gets large, the reciprocal of cosine is going to get small. So I'm going to guess that this is going to be my graph of secant right here. So whenever I see cosine of theta get really big, I'm going to make a very educated guess and say that cosecant is going to get very, very small. In fact, at its minimum. And when cosine is at its minimum, then secant of theta is at its maximum. So when cosine here is at its minimum, secant is probably going to look like this. And so I've been able to graph this using my knowledge of cosine and kind of using the pattern that we used last time with cosecant. Okay? And let's see if this is true before we proceed further. So go to my y equals, and I'm going to change things around. Instead of graphing sine, or 1 over sine, graph 1 over cosine. That's the same thing as secant. This right here is the same thing as secant. And down here, hit cosine, graph. And let's look at that. Looks like things are shaping up the way that I predicted it would. The one thing that I correct that in a minute. And there you have it. I'm going to go back to my handwork here. And the error occurs right here when I have the max of these things occurring right around -2. That's not going to be correct. It should be at -1. Okay, so I need to label this a little bit better. This is -1. Maybe like right here is -2, and down here should be -4. Because these points right here should occur at -1, not -2. Okay. Alright, so now we can analyze this, and it shouldn't be too difficult. Let's look at the vertical asymptotes. Use red, use a different color, mix things up a little bit. Vertical asymptotes. Well, it occurs at pi over 2, 3 pi over 2, and basically odd multiples of pi over 2. So this is pi over 2, 3 pi over 2, 5 pi over 2. If we were to continue this, negative pi over 2, and so on. So we can say that this is odd multiples of pi over 2. Okay. There are no horizontal asymptotes. We can say then that the domain, once again, is all real numbers except odd multiples of pi over 2. The range, very similar to the range for cosecant, it's everything from 1 upwards and from -1 downwards. So there's sort of a gap here in the middle. See, there's a gap here where the secant function never really touches. So we can say that this is everything from -infinity to -1 inclusive, and everything from 1 to positive infinity. Okay. Not counting positive infinity, of course. Few other facts here. This has all the extrema. It has a max at 1, and that's local. Oh, excuse me, a max at -1. These maximum points are actually at -1, and that's local. Has a minimum value at +1. These right here are actually minimum values, and that's also local. There's nothing absolute about any of this, and it has a period same as before. It's a little bit harder to visualize, but if I look at this box right here, from -pi over 2 to 3 pi over 2, that distance is 2 pi. And you can see that this box just gets repeated over and over again. And so the period is the same thing as the period for the cosine function. Okay, so we can see that for secant and cosecant, they just kind of sort of like the reciprocal. They are the reciprocal of sine and cosine, and their behavior reflects that in a way, because you can see that whenever cosine hits its peak, secant actually hits its low point. When cosine hits its low point, secant actually hits its high point, even though it's a local value. When cosine is 0, well, that's when you have these horizontal or these vertical asymptotes, excuse me. And the symmetry of this is actually even. The symmetry for this is even because it is, if you look at the orange graphs, only I know it's kind of hard to see with all this other stuff, but the left side of this is symmetrical to the right side of it. Okay, so the symmetry here is even. And these are some of the basic things that we have about, some information about secant and cosecant. You can certainly answer more questions like, is it bounded, is it unbounded, is it continuous or discontinuous, but from this information you can derive the rest of it. So thank you for watching. Again, in another video we are going to talk about what happens when we do transformations on these graphs.